Hey there, guys. Welcome back to the channel. I'm your buddy Shaunak, and today we are about to dive deep into the heart of microservice architecture, focusing on a very fundamental concept autonomy. What does it mean for a microservice to be autonomous, and why it is crucial in the world of distributed systems? Understanding autonomy in microservices not only helps services work independently and flexibly, but also sets foundation for creating strong and adaptable distributed systems. With autonomy, teams can innovate, adjust, and meet evolving needs smoothly, leading to much more efficient and scalable solutions.
Before we go deep into the technical aspects, let's explore the analogy of building a house. When building a house, you need various professionals to come together to make it a reality. You can think of them as external dependencies. We rely on their expertise, their contributions, but we cannot directly control their actions. If any of these experts face issue or delays in their work, it can lead to delay in the whole construction process. This holds true whether they face material shortages or some weather related problems or simply just take longer than expected. In a perfect world, we would be able to complete our work without relying on anyone else. At the same time, we don't want to do the entire job ourselves. Sharing the work with the team is what it allows us to scale. So, what does this have to do with microservices? Microservices are a team of applications working together to complete a task. These services often depend on each other, which creates external dependencies. These microservices often rely on one another, and guess what? It can lead to delays. Just like your contractor going on a vacation or getting sick, microservices can fail or they need to be redeployed. They can even get swamped and slow down and causing timeouts and failures in an otherwise a very smooth operation. The problem with both the house and the microservices is lack of autonomy. What's autonomy? Well, it's like having the freedom to make decisions on your own without anyone poking their nose in your business. Every time a microservice depends on another, it's like putting a little chain around its ankle, reducing its autonomy. Imagine you are running an e-commerce site with all sorts of data, customers, orders, shipments. Now, obviously, you need information from all these different sources to update an order status. The traditional way could be to just pull data from all these microservices, right? But guess what? This creates a lot of coupling between the sources, like a tangled headphone wires. So let's say one of your microservices decides to go take a coffee break and goes offline. In that case, the whole order status task would fail. What if there is a more flexible way to make the system more flexible? Imagine if instead of a microservices pulling data from each other, like it's a game of tug of war, they could just push their updates to and info to this central messaging platform. In Then what will happen? Instead of waiting until you ask about your order, the service responsible for the order status could consume all these messages and build a view of the order ahead of this time. So when you do check your order status, this way all the details are ready and waiting. There is no need for extra calls, things are faster. This also means that the different parts of system don't have to be super tight connected. It also breaks the temporal coupling. Okay, before they all had to work together at the exact same time due to the synchronous communication. But with this new architecture, they can work independently, like sending messages back and forth. This gives us more flexibility. Even if one part of the system goes offline, it doesn't immediately affect the others because they can still process messages when they come back online. In this example, When the order service is offline, it's still possible to obtain the shipping data or customer data because these two systems are fully functional. This improves the autonomy of each microservice and allows them to be more resilient. Let's discuss another mistake in the world of microservices, the temptation to pile everything into a single service. If everything lives in one service, then there is no external dependency. Sure, it seems convenient, but this creates its own problems. Alright, so picture this. You have got an e-commerce platform and it needs to handle orders, customers, shipments. Now you might think, hey, now why not put all of these together in a single basket like a super service? It seems convenient. And as long as everything is running smoothly, it's all good. They also share the same resources. So this is where the issue will come. So let's say, imagine there is a big product launch. Orders are starting pouring in like crazy. This super service, which handles everything, is like the epicenter of the action. Unfortunately, the entire system is now sharing processors, memories, threads. So when the orders do actually flood in, not only they get overloaded, they also hog all these computer resources. Now here's the problem. It's not just orders that is suffering. Suddenly, even completely unrelated things like shipments is also stopped responding. In a nutshell, when you pile everything together into one single super service, problems in one corner of the system can cause a ripple effect and it can go through the entire system. It's like a domino effect when one falling domino knocks down the whole rest of dominoes. So this is where microservice cohesion comes into play. Think of cohesion is like organizing your suitcase effectively. You wouldn't put your toothbrush with your socks, right? For example, adding, removing item from an order. They are highly cohesive operations because they both deal with the same entity, the order itself. But adding an order and adding an customer, these are not cohesive because their entity involved is entirely different. So you probably heard about the single responsibility principle, right? The principle states that a class should have only one reason to change. It's like having one job and doing it well. This principle, coined by Robert C. Martin, it says that class should have only one reason to change. But in our case, we can take it as a microservice should have only one reason to change. Now let's apply this principle to microservices. When you are adding or removing items from an order, the reason for change is clear because the order is getting updated. So this fits perfectly within the rules of single responsibility principle. But when you start mixing unrelated tasks like adding an order, adding customer, you have got two completely different reasons for change. It's like trying to juggle apples and oranges and it violates the single responsibility principle. So here is the deal. If tasks involve different entities, they probably don't belong in the same microservice. This is where the domain-driven design introduced by Eric Evans also comes into play. Evans introduced the concept in something called bounded context. Think of them as clear zones within their own language or rules within a larger system. Large systems can be divided into smaller bounded contexts based on these boundaries. Bounded contexts are like again fences for your backyard, introducing clear boundaries within fewer connections. So picture this low coupling. Low coupling change means that just changes in one microservice won't send shockwaves through the entire system. It's like having separate compartments in a ship. If one takes on water, the others remain float. And high cohesion? High cohesion means that related changes are grouped together in the same microservice. So, making them easy to find and manage. It's like having your tools neatly organized in a toolbox.
Finally, remember that when building autonomous microservices, you want requests to be answered quickly without relying on external dependencies. And changes should be isolated to just one service, making your life a whole lot easier. So that wraps up our discussion on the importance of autonomy in microservices. Remember, autonomy helps each service work on its own and contributes to making our system strong and adaptable. Thank you for joining me in this exploration. If you found this video helpful, don't forget to like, subscribe, and hit that bell icon for notifications on future content. And as always, keep coding, keep innovating, and keep pushing the boundaries of what's possible in the world of tech today. Until next time, this is Sonak signing off.